This program will focus on one of the more common reactions of alkanes, free radical substitution. Firstly, let's examine what's meant by substitution. Here I have methane and chlorine. And what will happen in our substitution reaction is the hydrogen will be substituted for by a chlorine from our halogen. The resulting products will then be hydrogen chloride and chloromethane. Alkanes are generally unreactive. The main reason they're unreactive is the very strong bonds that are present, carbon-carbon in larger alkanes and carbon-hydrogen bonds as well. The weak bond that exists here is the chlorine to chlorine, and it's possible with UV light that you can break that bond, and that's how this reaction is started. So one of the important things in this reaction is the condition that's needed to get the reaction started. I place that condition above the reacting arrow. Finally, my product itself, chloromethane, I can alter that product by increasing the ratio of chlorine to methane in my original mixture. So I can get it more than one substitution occurring. I could get a second chlorine attaching, or even a third to make trichloromethane, and even in some cases tetrachloromethane. I want to examine this mechanism a little bit more deeply. What I mean by that is a step-by-step approach to what's going on in the reaction. We'll begin with what's the initiation step. It begins with UV light breaking apart by means of homolytic fission our chlorine gas. Homolytic meaning they both get one electron, and that results in the formation of two chlorine radicals. I'm going to replace this now with the more conventional picture where the unbonded pairs aren't shown and we only show the bonded pairs of electrons as a straight line. This is probably more typical to what you might have in your notes or in a textbook. The curved arrow we use is somewhat important because it represents the motion of electrons. The fact that it has one harpoon on its end indicates the movement of one electron. Later on we'll see with a double-headed arrow that represents the movement of two electrons. But for now in this mechanism we only need the movement of one electron towards each chlorine. The next steps are called the growth or propagation steps. I begin with my chlorine radical interacting with a methane, and the hydrogen and one of its electrons will join that radical, resulting in the formation of hydrogen chloride and forming a new radical, the methyl radical. Again, I'll replace it with the more conventional line technique. Now I'm going to take my methyl radical and have it collide with a chlorine that is not split by the UV light. A chlorine atom and one of the electrons in the bond will then form our chloromethane and reform our chloride radical. Notice that this chlorine radical can then go back to the initial step in the propagation and reform a methyl radical. And so we begin a cycle. There is an alternative path that can take place where our chlorine radical collides with a chloromethane and will produce another hydrogen chloride and dichloromethane. But I'm going to focus on this mechanism. Finally, there are what we call our termination steps. And there's three possible termination steps. They involve collisions of radicals. So I could have a chlorine radical colliding with a second chlorine radical to reform chlorine gas. I could have a chloride radical colliding with a methyl radical to form chloromethane. And finally, two methyl radicals collide to form ethane. I'm going to replace these now with their more conventional line technique. One thing I'd like you to note from this is that initiation steps result in the formation of two radicals, two radical products. Propagation steps have a radical as both a reactant and a product. Termination steps result from the collision of two reacting radicals. Thanks for watching.